Hey YouTube, it's me again. I didn't record at all in the car on the way to the golf course to go flying last time because I didn't drive. I got picked up, and kind of wish I recorded that conversation. We had an interesting conversation about air conditioners in cars on the way there. I don't know if that's interesting to you, but I thought it was fun. I got stuck in a tree again. I'll probably put some of that footage in here. I've been monkeying around with the rates on my 5-inch, well, on all my quads, but specifically on my 5-inch quad yesterday. I've been trying to do a juicy flick for a long time. I'll try it 8 or 9 times almost every time I go out, and I always goof it up. Now, I don't know if this is really should be called the juicy flick or not, but 2 years ago, Joshua Bardwell and Wild Willie did a video about how to do a juicy flick, and it was an entirely different thing than what Wild Willie told us a juicy flick is a few months ago. So I don't know, but it's the move where you approach whatever, do a half of a front flip pretty fast, and then do a slower, pretty fast but slower roll, and then you do a half yaw to come out of it. And every time I did it with my old rates, I never ended up facing behind me, directly behind me. I'd always be off by about 20 or 30 degrees. And everybody's been talking about running lower rates this last week or so, all on account of Joshua Bardwell and Captain Vanover. And I figured, well, let's try it in the simulator. It was raining all week, so why not? Went into liftoff. I wanted to try this new Bando City map anyway. And boy, I just started dropping my rates about 100 degrees a second, 200 degrees per second. I ended up going from, I was at a max of 909 degrees, and I settled in at about 674 degrees per second. And I changed my expo. About the middle half of the graph is at about the same slope as it was before, and now just the elbow at the end just isn't as severe, and it's working great. I couldn't believe it the first time I even tried a juicy flick in there. It just worked. Started looping around. I started doing S turns and juicy flicks around the same excavator on the map, and I could just do them over and over and over again. I didn't understand why this is working. I figured it's got to be the simulator. I always tell people that I'm 7 times better at flying in the simulator than I am in real life. But, I went out, and first non-rainy day was a Saturday. Every time I was doing them just fine. I don't understand. Still having a little trouble doing them close to the ground. I don't have the simulator goofed up my throttle thumb. My real quad responds a little slower than the one in the simulator. But none of that matters. That's not really, I shouldn't be here talking about this. I finally broke one of my Kestrels. This is my 4-inch Kestrel, and he's got really nasty props on here today. Can we get Judy to track the quadcopter instead of my face? Really messed up the props getting stuck in a tree yesterday. Is that where I messed them up? I don't even know where I messed up the props. But the most important thing that I did here, finally, I broke an arm. Broken arm. It's at the base. I feel stupid about this, and I'm going to fix this in the design. This is an earlier prototype arm. I hope she's focused on that. Do you think she'll focus on that? I don't even know how close I can get with this, but do you see that that narrow spot in the middle? That's where it broke. And I figured the arms are 3 millimeters thick and about 6 or 7 millimeters wide, and I thought for sure that it would be on the outside of the mounting screw where it would break. But no, this one managed to break in between. This is an old prototype that used 2 screws. The new one does not use a second screw. There's on the inside here, there's a little dog bone piece that ties all 4 arms together. But that's not important. It still has these same cutouts. One of these cutouts has to be there for the stack. You can't get the stack screws in and out without this cutout. Well, this cutout. But I'm going to eliminate that one, and we'll just make the arm stronger. But I'm glad that happened before we manufactured any of these and started sending them out, because I would have been sad if I sent everybody fragile arms. But I'm really surprised. These spindly little 3mm arms on the 4-inch, they're... I don't know how long they are. But we can measure them. Ooh! Look at this. I have some kind of a... Oh, geez, she lost me. I'm right here, Judy. Judy! There she goes. The arms are... Oh, geez, this is metric. To the center of the motor from the first screw, mounting screw there, it's about 7.5 centimeters. So that's 3 inches? Does that seem right? I apparently don't know how long 3 inches is. So the 4-inch arms are 3 inches long, because 4-inch props are really 2-inch blades, right? So that makes some sense. But I sure thought these little spindly little arms were going to break, and they have not, other than this weak spot that I put in there. I measured that on a caliper. It's 4 millimeters wide. The arm is 6.5 or 7. I forget what I set it to last. Wide and 3 millimeters thick, and at that weak spot, it's only 4 millimeters. We'll bring that up. That'll be close to. It might even be 7 millimeters by the time I take that little notch out of there. But yeah, do you guys want to see how I fix that? Is that fun? Let's give it a try here. Let's see if I can get OBS working. Now, this window on the right is Emacs. That's my text editor where I edit all my source code. And this window on the left is OpenSCAD. Every time I save the file in Emacs, OpenSCAD will render my changes over here in this view. And this section here of the Kestrel source code is where you decide what you want to see rendered. You know, if I'm cutting arms, I've got this line here. If you set that to true, it'll show the 1 millimeter parts, so I can cut all the 1 millimeter parts together, and the 2 millimeters, all the 2 millimeter carbon fiber. What we want to see is the arms and the wedge. The wedge is the little eye-shaped doodad that holds the arms together. It's used to be 2 screws per arm, but I ended up putting one of these in the middle to keep the arms from jiggling around. It works pretty well, and it's a few grams lighter, and it seems pretty sturdy. So here are our arms. What we have to get rid of, this notch on the middle part of the quad, that's where the stack screws go. And it needs to be pretty big because you might run an M3 stack and you need M3 screws, and those screw heads are pretty big and they have to fit here. My 4-inch uses an M3 stack. But this other gap here, this other cutout that I put in here to save weight, that has to go. So we're going to look for, OpenSCAD uses functions just like any programming language. In here we're calling them, they're called modules. So what we're looking for is a module called ARM. And it's right here. She keeps forgetting my zoom, Judy. So ARM, you can specify an angle and a length when you call this function, and we call that function 4 times somewhere else in the source code. And it figures out the length, the placement for the motor based on, you know, math here, some trigonometry. And we have to find the spot where this cutout is, and I don't remember where it is. You can put a pound in front of a line, and it's going to take it about 10 or 15 seconds to re-render this here, and that will show that cylinder here in red, whether it's part of the model or not. It might be something that's cut out with a difference. That's how we build everything in OpenSCAD, is differences in unions and hulls of various simple parts like spheres, cubes, and cylinders. And a hull is one of the more interesting objects. So you can see this is a hull, and of 2 objects. It's a cylinder and a cube, and you can see each of those pairs of cylinders and cubes over here. The cylinder is where one of the bolt holes goes to hold the arm on, and the flat side is where the arms meet in the middle. So what I've done is I've built this hull of where everything is going to mount, and then I have a difference that starts pulling little bits of those. Pulls that cylinder out, these two cylinders. There's functions that do that. We don't need to know most of that, but I do kind of know which cylinder we're looking for. This one's going to be the wrong cylinder. I know these are the right ones because they're kind of manual, and I know I did these cutouts pretty manually. I like to have variables up at the top of the source code for all my important values so that you can change them once and they change everywhere. But these, I just kind of eyeballed them to see how big they should be. That's the wrong one. This circle needs to be cut out or it's not going to work. We won't be able to put a stack in. And I goofed up those cutouts on one of the builds and I had to file it out by hand. That was a pain. So here's the cylinder that needs to go, right? That's the one on the outside. So we'll just comment it out with a couple of slashes here and we'll save that. And we're good to go. That's the new Kestrel arms. If you need them in 4-inch like we do, you'll see I have a file here. I have an include. I broke out the stuff that's specific to a particular arm geometry. My goal is to have the fuselage of the Kestrel be the same in all builds, but I want the arms to be different. If you want to run 4-inch props, you put 4-inch arms on the same fuselage. If you want to run 5-inch or 6-inch arms, 6-inch is going to be ridiculous. 5-inch might not be too weird. I haven't cut any yet to find out. But you just change some of these values. So instead, I'm going to comment out the 3-inch arms. Do you hear my friend Harley in the background? He doesn't like that the door is closed. But we'll uncomment the 4-inch arms and we'll save it, and there they go. They get longer. The wedges are in the way now, but they get longer. And if we take a look here, let's not do the compact arms. Let's do the long, because that's the one I like to fly. We have prop diameters in here. We have lengths and angles for the front and rear arms. The angles may not be quite what you think. In your mind, you might think they're from the dead center of the quad out, but I'm not smart enough to have done that. They're the fulcrum of the arm is this mounting point on a 30, and that they fit right at the points of a 30 by 30 stack. So the length here says 60 millimeters, and that's from the 30 by 30 stack out to the center of the motor. And that's where the angles come in also. And a 3-inch quad uses M2 holes for an 1106 or a 13, 14, 1606, 1408, whatever motor. And you can find two different diameters. You can do an inner and an outer diameter for the motor holes. And that winds up there. I use the hull, so that cuts out an oval. It's not really an oval, it's an oval-ish. I don't know what you call that. So you can mount either size motor on the same arm. And the 3-inch arms are 6 inches wide. If we take a look at the 4-inch, I skipped the 9 millimeter diameter holes because I can't imagine running 1106 motors or smaller on 4-inch. And I've bumped up the arm width to 7 millimeters. I didn't know if that'd be enough. I think it's enough, though. And you can see we bumped up the prop diameter. The angles are a little different. The lengths are a little longer. Just 15 millimeters, so it's not huge. But I've got some notes in here up at the top. But yeah, that's how we edit the Kestrel. Well, that's all I'm going to say about the Kestrel for now. I'm glad I didn't run out and manufacture these as, even though I thought I was ready to, because I would have been bummed out if I sent them out with those weaker arms to save that probably saves 1/10 of a gram. It's probably something stupid. But these new arms should be stronger. So I think I've been flying mine. Brian's been flying his. I've been flying both of mine. They're both holding up to a lot of crashes. I crash a lot. I really do crash a lot. And they're holding up better than I expected. Since I was trying to get a lighter quad than the Acrobat, I figured I'd be giving up too much material and making it a little too fragile. It might not be great at a big concrete bando, but it's fantastic at the park. I've crashed into concrete a few times though, so I don't know. It's not too bad. It's not too heavy. But yeah, if you like what I'm doing, you can check out my blog if you want to read more about the Kestrel, and I have some other videos where I talked about it. If you like what I'm doing, let me know. Leave a comment. If you're interested in my frame, if you want to buy one, leave a comment. I can't sell you one yet, but I'm very interested in knowing how many I need to buy when I have the first run manufactured. So let me know. And yeah, if you really want to see this manufactured, like the video, subscribe to my channel, share it with your friends, let other people know, because the more people that know about it, the easier it is for me to, the more of these I can have made, the cheaper they cost and the better of a deal I can give you guys, and that's really what I'm interested in. I don't want to make a ton of money. I just want to make enough to work on the next project, right? And get you guys flying my frame. That'd be pretty cool. But I'm going to leave you guys with some footage from me and Brian and Mike trying to get my quad out of a tree last week. It's the second week in a row I got that same quad stuck in the same tree. Except this time, Brian was flying my quad. He was trying my new rates. And I told him I wanted to see him do a power loop. And he did one, and he did fine. But on the second one, he whiffed and came right down into the top of the tree. My 20-foot PVC pole was not long enough. We had to go buy a Mr. Long Arm 23-foot painter's extension doodad over at the Lowe's. It was fun. We did a good job. You guys have a good day.